What's so amazing about bird feathers? That's what we're going to find out today. Hi, this is Jill from the Northwoods talking about nature right outside your front door. Some, when they think about birds and why birds are so amazing, they might say, oh, beautiful songs, or that the fact that they can fly, or their incredible migration. I'd argue one of the most incredible things that we walk past all the time is one of the most complex structures in the entire animal kingdom, and that's feathers. And feathers are amazing because they are little engineering miracles. The facts will make you look at feathers differently from now on. And whether you're 6 years old or 60 years old, stick around because feathers are genuinely one of the most awe-dropping inventions out there. And so let's get a little bit into it. Feathers are basically what is a feather? You touch one, and you probably have, and it blows across the table. Have a bird, have a pet bird. Feathers are flying around all the time. But when you look at it up closely, what you see is that, first of all, it's made of keratin. That's the same protein that makes up your fingernails, your hair. So in a sense, a feather is a fancy hair. But similarly, it also is a little bit like your fingernails, where there's a hard bit in there too. And what really blows my mind when I take a look at what feathers are is that it's a tiny zipper running down the center of a stiff shaft. That there's dozens of little branches called barbs, and each of these barbs grow a little tiny branch in there called barbules. And the barbules have little hooks on them, almost like little Velcro, and those interlock, holding together with its neighbor, locking this all into place so that you sort of get this smooth, flat surfaces. And so if you rub a feather the wrong way, the barbs come apart, and then the feathers start to look scraggly and rough. When my bird is losing and molting his feathers, he looks rough. And what birds tend to do with the feathers is they pick up the feather, it's preening, and they sort of zip those hooks back together with their beak as it's still on them. And then they look as good as new. Birds do preening all the time. It's maintenance. It's running a quality check on hundreds of little zippers every day. The fun thing, and you can try if you find a feather, like I said, I have a bird that has feathers, is you can smooth them back between your thumb and forefinger, and you actually feel them zip back into place. Kind of one of those satisfying things in nature and totally free. So if you look at birds and their feathers, you might not realize that there's not just one kind of feather out there. There's a whole wardrobe of feathers, different feathers for different jobs that go through some sort of main feature. There's contour feathers out there, and these are the feathers that are on the outside. Generally, when you draw a sketch of a bird, they're sleek, they're waterproof, they give that bird the shape and the color that you see on the birds. And you can think of it as a bird's outer jacket. Underneath those feathers, you get down feathers. And down feathers are completely different, soft, fluffy, and they don't have those interlocking hooks. Instead, the barbules just float free. And they trap little pockets of warm air next to the bird's body. And so it's essentially like a little sleeping bag. If you know anything about sleeping out in cold, I'm a camper, that you need air pockets, and that air pockets gets warm from our body temperature, and then those air pockets keep us warm later. Baby birds and chicks are almost entirely covered in down. That's why they look so soft and fuzzy all the time and irresistible to pet. Don't pet them. But that's why when we have winter coats and pillows, they're down. They're made with down. And we have figured out through our technology how to also make synthetic-like air pockets the same way. Then there's something that's called flight feathers. Those are long, stiff feathers on the wings and the tails. They are asymmetrical, meaning there's two sides of the feather aren't equal. The front is narrower than the back edge, and the asymmetry is allowing them to fly. It helps generate lift to get the bird up, similar to an airplane, shaped wing, and the aerodynamics is amazing. We can, think about the Wright brothers who spent a lot of time trying to figure this out. The birds had it down. So there's also this type that is called the phyloflume, and these are tiny little hair-like feathers scattered amongst the bigger ones. Scientists think that these act as a touch sensor, tells the bird when the outer feather shifts positions, they know when to preen. They know that this zipper is getting out of shape. And so that gives them a first indication to do that. Then my next personal favorite feather is called the bristle feather. These are stiff, spiky feathers found around the face and the eyes. Flycatchers, have that insect that they snatch out of air. They bristle the crest. They bristle the area around their mouth to help them funnel the bugs in. They sort of build like a little bug net right there on their faces, and that's one of my favorite bird things out there. If you talk about color, and this is where feathers are just unremarkably cool, is some feathers are darker from pigments than the actual chemical color of the feathers on the outside. Cardinals are red because of pigment. Many sparrows are brown because of a pigment called melanin. It's pretty straightforward. It's why we get, brown hair too. But they get their dazzling colors in the bird world. We think of birds as being beautiful. It doesn't just come entirely from the pigment. Sometimes it just comes from light itself. Iridescent blue of the kingfisher, diving down in a stream, the shimmering green of a hummingbird hovering over a flower, the eye-popping teal that you might see, or purple in a peacock's tail, none of that is actually colors in the feather. There's no blue pigment in a kingfisher feather. What's actually happening is the feather has a microscopic layer structure, tinier than anything you could see with the naked eye, and those layered structures scatter the light in the same way like a soap bubble scatters a light and creates a rainbow. You get those distinct colors on a oil slick, on a wet road. This is what scientists call structural color. It's created by the actual structure of the feather itself, changing the light based on the angle you're looking at, the tilt of the feather this way or that way. It can glow green, it can glow blue, tilted another way, and it can shift to more of a bronze or a brown. The feather itself hasn't changed. The light itself has changed. And we have only recently figured out how to replicate things like this in, think of anti-counterfeiting technology on a banknote or high-tech fabrics. It's something that we just learned just recently. And it's pretty amazing because when these lights shift in that particular change of color, sometimes I see this in mallards, that mallards are green, and sometimes they look a little purple, and you're like, did that mallard just turn purple? And it's just the way the light shifts. We've seen it in blue jays, too. On a gray, gloomy day like it was out today, blue jays look gray and gloomy. But on a bright, sunny day, blue jays are sharp blue and just stunning looking. So you can kind of get that hint that it's actually how the light is changing in the feathers, not actually the feather colors itself. And we can't talk about feathers without talking about what they're mostly built for, which is flight. One bird that particularly deserves to be in the spotlight when it comes is the owl. Owls are famous for their silent flight. If you've ever been near one, and I have, I took a canoe trip where an owl flew right over my head. I didn't hear a thing. It's ghostly quiet. A hawk and a pigeon, they flap and make whooshing noises, but an owl can glide past you in almost total silence. And their feathers are in this comb-like structure along the leading edge, tiny serrations, like a fine-toothed comb that breaks up the air turbulence so that they don't create any noise at all. Other feathers have a velvety texture that absorbs rather than reflecting the sound. And that results in a bird that can fly right over your head, right over a mouse's head in a field, in complete silence. The mouse has no idea an owl is about to descend on it. For an owl, quiet feathers aren't just impressive, but instead, they are the difference between them eating and going hungry. And at the other end of the spectrum, you might have what is called a cassowary. If you've ever seen them, go Google them. Crazy looking bird, huge, flightless, comes from Australia and New Guinea, and their feathers have lost all the barbule hooks. So instead of being smooth, They are long and droopy and hair-like, and they almost look like a shaggy black fur coat. It's one of the most unusual birds on the planet, but that's why it happens. So let's take a look at some basic fun facts. I always think about Sheldon and Big Bang Theory about his fun facts. But let's talk about some fun facts about feathers. Hummingbirds have around 1,000 total feathers, the fewest of any bird on Earth. A tundra swan, on the other hand, can have 25,000 feathers, most of them dense down that helps them survive the Arctic winter. The bird's entire set of feathers is called plumage, and they often weigh more than the skeleton of the birds, all the bones of the birds added up together, because their bones are hollow to save weight. Birds replace their feather through a process called molting. My bird molts usually once or twice a year. Some ducks shed almost entirely all their feathers at once and are completely flightless for several weeks. Canadian geese are like that too. And then the new ones grow in. The longest feather ever recorded belonged to an ornamental breed of rooster in Japan, and their tail feathers grow over 30 feet long. 30! Flamingos are not naturally pink. They turn pink from eating algae and crustacea, and that turns their feathers pink. And so sometimes when you see them in captivity, if they're not fed the right diet, they'll turn almost all white. Some birds, like woodpeckers, like kingfishers, have specialized feathers around their nostrils that filter out sawdust and dirt that they kick up while driving into the wood or diving into the water. And finally, birds can feel pain in their feathers, kind of. The follicles where the feathers have grown have nerve endings, and once their feather is fully grown, it has no feeling at all. But while growing, it's called blood feathers, are very sensitive, and that's why you'll see birds react when you touch a new feather that is still developing. You always want to handle with care if you have a pet bird in that situation. And so I hope that helps you understand bird feathers a little bit better. So the next time you see a bird land on a fence post, or you find a feather lying in your backyard or on your walking path, you'll give it a second look and really take a deep dive look at it. The feather structure is more complex than anything we have when it comes to our hair and our fingernails. It can zip up, it can unzip itself, it can make color. It can make color from pigment or color from light. It can muffle sound or make more sound. It can trap heat in, and it can slice through the air and cause flight or survive being soaked. And all of this just makes a bird's existence incredibly amazing. I am always so impressed by the miracle of nature, and it's so extraordinary just to look around nature outside your front door. Thank you so much for listening. I hope you're enjoying the podcast, whether you're a kid, a parent, or a grandparent, or anyone who's ever stopped by to look at a bird and wonder, hey, what's going on behind those tiny eyes? Appreciate you being out there. You can email me at jill@startwithsmallsteps.com. Leave a comment right here. Share this with a friend if you want to know a little bit about nature right around your yard. Thanks so much.